All right, here we are in the land of polynomials. Sounds kind of ethereal, doesn't it? And in this land of polynomials, in this video, we're going to be practicing division. So in previous videos, we've talked about addition and subtraction. We've done distributing via multiplication. That was in the previous video. And now we're going to cover division. And when we're dividing polynomials, we're going to divide by a couple of different kinds of polynomials. We're going to divide by a monomial first, which is a polynomial that only has one term. And then we're going to divide by a binomial. And the task of dividing by a binomial can be accomplished a couple of different ways, and we're going to look at both techniques. One is when you're dividing using a long division, and the other is when you divide using synthetic division. And I'll show you an example of each. First up is dividing by a monomial. And here in this yellow box, you see a very generic version of that. First is a plus b divided by c, and I like to call this the distributive property of division. And indeed, it's kind of a real thing. Division and multiplication, if you think about PEMDAS, P-E-M-D-A-S, parentheses and exponents come first, and then really multiplication and division are next to each other because they have the same priority level. Except PEDMAS, I think, just doesn't have the same ring to it. Nor does PEMDSA. You wouldn't want to switch the A and the S. So we do addition and subtraction. But addition and subtraction abide by the same rules also. So following that, it makes sense that we have to distribute our division the same way that we distribute our multiplication. And we're seeing that here. Excuse me. A plus b is being divided by c, and in order to do that, we need to take the a and divide it by c, and separately the b divided by c. Think of this in reverse also. What do you need in order to add two fractions together? You need a common denominator. We have it already. C is the common denominator. And once you have your common denominator, how do you add your fractions together? You add the numerators together, and you put their sum over the common denominator. We're just doing that in reverse. We're tearing it apart, whereas previously we learned how to put them together. Similarly, it works the same way for subtraction. We do still have to distribute our division. All right, let's give it a try. In problem number 1's too easy. Let's do problem number 3. That looks a little bit more challenging anyway. And I think that when a problem starts to look this complex, it's got some moving parts here. Let's go ahead and actually write out the distributed division. So we have the 20x to the 4 divided by negative 4x to the 4. And I'm going to do something a little unusual. I'm going to write plus negative 16x squared over negative 4x to the 4. And then plus, so that I'm using plus every time, here's the positive 12x to the 6 over a negative 4x to the 4. You can do it this way. Could I have, instead of adding a negative 16, could I have just put minus here and left this without this and just had it been minus a positive 16? Absolutely. All right, so now let's simplify. 20 divided by negative 4 is equal to negative 5. And x to the 4th over x to the 4th. 4 minus 4 is 0, so you've got x to the 0. We know that anything to the 0 power is equal to 1. So that cancels out. We're really multiplying by 1. Plus, negative divided by a negative makes a positive. 16 over 4 is 4. Upper exponent minus lower exponent leaves us with x to the negative 2nd power. And then here, we've got a positive divided by a negative, which is a negative. 12 over 4 is 3. Upper exponent minus the lower exponent, that is x to the 2nd power. You could present this as your final answer, or you could change the middle term to say plus 4 times 1 over x to the positive second power. We took the reciprocal because of the negative exponent. Remember that 4 is the same thing as 4 over 1, so we could think of this as plus 4 over x squared. Bring down the negative 5, bring down the minus 3x squared, and this is another very reasonable way to write your final answer. If it were a free response question on a test or a quiz, I would definitely accept either one of those. If you're typing your answer into an online service, there might be some specific instructions that say, write your answer only using positive exponents, in which case you would need to use this second option here. So that is dividing a polynomial by a monomial. Then we move into long division. So you can see in this example, let me switch colors, that I'm taking a polynomial in the numerator, it's a trinomial, and I'm dividing it by x plus 7, a binomial. So one way to do that is using long division. And I'm not going to do that one. I think I'm going to do number 5 instead. And I don't quite have enough space to work this out. So what I'm going to do is open up a notepad, if I can. Close. There we go. All right, so now I can copy that problem. Can I just squeeze that down a little? Perfect. All right. So no, I don't need I just need to be able to write some stuff. I don't need all those folders. There we go. All right, so let's set this up like a long division problem. We've got x plus 7 is dividing into, oh no, I didn't want to do that one. Sorry. Let's do number 5. Here it is. Clear those. Okay, we're going to take x minus 4 and we're going to divide it into, now here's why I wanted to do this problem. We're going to take x minus 4 and we're going to divide it into this other polynomial, 2x to the third, blah, blah, blah. So I'm going to write down the 2x to the third under here. And then I want you to realize that there are no x squareds in the numerator. And when that happens, when you're missing a term, sort of, you need to put in a placeholder. So I'm going to put in plus 0x squared. You must do this so that everything lines up and you end up getting the right answer. Then we'll put the minus 38x and the plus 24. All right, let's start the long division process. It's a little unusual. It's very similar to what you used to do when you first learned how to do long division just with numbers. And what we used to ask ourselves was, if, let me see if I can just put a little supplemental problem up here. What if I was dividing 3? What if I was dividing 3 into, oh, I'm off screen there. What if I was dividing 3 into 127? Well, 3 goes into 1 0 times, and then 3 goes into 12 4 times. 4 times 3 makes 12, and we would do subtraction and get 0, and then we would bring down the 7, and we'd say 3 goes into 7 how many times? 2 times, and then we would take the 2 times the 3 and get 6, and we would do subtraction again, we'd get a 1, and that 1 would be our remainder. You could just write a little lowercase r with a 1 next to it, or you can take the 1 left over and still divide it by 3. All right, if it had been a remainder of 0, we'd say it goes in evenly. But when we end up with this remainder, you've got the two options. You just note that there's a remainder, or you can take the remainder and divide it by the divisor. And I go through all of that because that's exactly what we're going to be doing when we're doing our division with polynomials. So I ask you, how many times does x go into 2x to the third? That's a pretty strange question, and most students who I ask that question don't answer correctly. So then I rephrase the question, and I ask it like this. X times what would equal 2x to the third? And that question, a lot more students get correct, and they answer 2x squared. And that is indeed correct, and I'm going to confirm that because I'm going to take this 2x squared now, and I'm going to multiply it by the entire divisor. So check this out. 2x squared times x makes 2x to the third, and 2x squared times -4 makes negative 8x squared. And we are going to do subtraction. And I like to put my subtraction sign in parentheses like that. Now notice that I wrote this 2x squared over my x squared term in the radicand. Or sorry, in the dividend. This is the dividend, the stuff underneath the division symbol. So I'm keeping all of my columns lined up. All my cubes are here, all my squares are here, my linear factors are going to be here, my constant factors are all going to, or terms are all going to line up there. So I'm being very organized about this as my battery runs out. So now let's do the subtraction. 2x to the third minus 2x to the third is 0. That needs to happen every time. If you're not getting a 0 there, then you did something wrong. And then we've got 0x squared minus negative 8x squared. So be careful with the double negative. It does turn into addition and give us positive 8x squared. And then we do what we did when we were kids. We bring down the next, it's not the next digit anymore, now it's the next term, minus 38x. And then we repeat the process. X times what would give me 8x squared? And the answer is positive 8x. So I write positive 8x. Notice that all of my x terms, x to the first powers, those are all lining up. And then I take the 8x and I multiply it by my entire divisor. 8x times x makes 8x squared. And 8x times -4 makes negative 32x. And we do subtraction. Minus sign in parentheses. The 8x squareds are canceling out. Perfect, I'm on the right track. Negative 38x minus negative 32. Watch the double negative, it turns into addition, and we get negative 6x. Bring down your next term, plus 24. Repeat the process. This x times what would give me negative 6x? The answer is negative 6. So I put my negative 6 up top, and then I take the negative 6 and I multiply it by my entire divisor. Very repetitive process. Negative 6 times x is negative 6x. Negative 6 times -4 is positive 24. We put our line, we put our minus sign in parentheses. We do the subtraction, both of those cancel out, and we get a remainder of 0. Which means the same thing it meant in 3rd grade or whenever we learned how to do division. It means that it divided in evenly. Now, this is a little bit mind-blowing. Remember, well, don't remember, but just as a separate example, if you take 3 and you divide it into 6, you get 2, right? 3 goes into 6 2 times. Now check this out. The answer to that division problem was called the quotient. If you take the quotient and you multiply it by the divisor, you get the dividend. It works the same in the problem that we just did up here. If we took this quotient and we multiplied it by this divisor, we'd have to do a superfoil and combine like terms. But if we did, we would get this dividend. So what we've just done using long division is we have started factoring our dividend, this 2x cubed thing. It equals the product of the divisor and the quotient. So as we continue moving toward learning more about factoring, please realize that this long division process is going to be beneficial. It'll be helpful. All right, let's see what else we have over here. So the answer, I apologize, the answer to this division problem is this. That's the quotient, and the quotient is the result of doing division, and that's our answer. All right, I'm at 5% battery. Let's see if we can sneak in a little synthetic division. Closing the door to keep out any noises out there. Okay, let's do number 10, and I think number 10 we can fit right onto this page here. Yes. So here we're going to do synthetic division. And synthetic division, as it says in this yellow box, can only be done. I'm trying to slide the screen over and I'm drawing with my finger, sorry. There we go. As it says in this yellow box, we can only do synthetic division when we're dividing by a polynomial that's first degree. So that says x minus r. Could we divide by 2x minus 5? You can, but I would modify the process a little bit. I think maybe if it says 2x minus 5, I would still do long division. You could work it and be able to do synthetic division, but easier would be to do long division. But if it's a very simple divisor like x minus 2, we can do synthetic division. And the first step in synthetic division is to find the zero of the divisor. Find zero of divisor. And to do that, I'm going to take x minus 2, set it equal to 0, solve, and get x equals 2. Now the 2 that I just found is the 2 that I'm putting in this little kind of box here. And then next to that box, I'm going to put the coefficients of my dividend, the thing that I'm dividing into. Now we're going to have some placeholders here also. How many x to the 5s do I have? I have 1 of them. How many x to the 4s do I have? 0. How many x to the 3rds do I have? 0. How many x squareds do I have? 1. How many x to the first powers do I have? 0. And what's my constant value? -2. Now if you're using lined paper, too dark. If you're using lined paper, I'll have you skip a line and then draw a line and take this first digit, whatever it is, it happens to be a 1, and write it below the line. So this is the setup for the synthetic division process. And now we're going to do this repetitive process similar to how we did in long division. I'm going to take the number 2 from the box, and I'm going to multiply it by this number that's below the line. So 2 times 1 equals 1. And then I'm going to add vertically. 0 plus 1 makes 1. And then I repeat that process. The number from the box, which is a 2, times the number below the line, which is a 1. I'm thinking, I'm talking, I'm writing, I'm worried that my iPad's going to run out of battery, and I can't do multiplication. Let's try that again. We take the number from the box, which is a 2, we multiply it by the number below the line, which is a 1. 2 times 1 is, you guessed it, 2. And we add vertically. 0 plus 2 is 2. Okay, now let's repeat the process. The number from the box times the number below the line, that's a 2 times a 2. That's equal to 4, and we add vertically. 0 plus 4 gives us 4. Repeat the process. 2 from the box times 4 from below the line. 2 times 4 equals 8. Add vertically, we get 9. Repeat. 2 times 9 equals 18. Add vertically. 18. 0 plus 18 is 18. Repeat. 2 times 18 makes 36. 2 times 18 equals 36. Add vertically. -2 plus 36 is positive 34. The last number that you get is the remainder. There it is, remainder. Now remember what we did. Look back over at the original problem with me. We're taking a 5th degree polynomial and dividing it by a 1st degree polynomial. What's x to the 5 over x to the 1? Upper minus lower, it's x to the 4. That's what this 1 represents. It represents how many x to the 4s I have. So I'm going to interpret that as x to the 4 plus 2x to the 3 plus 4x squared plus 9x to the 1 plus 18 as a constant. And then here's where it's a little different, but a little bit the same. I'm going to take the remainder and divide it by the divisor, just like we did in that first sort of old school long division problem that I did, where we had a remainder of 1 and we divided it by 3. I'm going to take this remainder of 34 and I'm going to divide it by my divisor of x minus 2. So that part's the same. Remainder divided by the divisor. The difference comes here. There needs to be a plus sign right here. This, ladies and gentlemen, is your final answer after having done synthetic division in order to complete polynomial division. And I did it. I'm at 3% battery, so I'm going to get out of here before this thing cuts me off. Thanks for joining me to review some synthetic and long division and polynomial division. If you search my channel, I've got some other videos, or at least one other video, where I do polynomial and long division. I'll see what I can do to get a link to those in the description for this video. Thanks for joining me. See you next time.